Ladies and gentlemen, welcome to the Animal-Based Dad podcast. This is the show where between my guest interviews with subject matter experts and topic-specific deep dives, the aim is to arm you with actionable insights and information on how to prioritize your metabolic health and improve your overall health and well-being. Ladies and gentlemen, welcome to the Animal-Based Dad podcast. I'm your host, Ricky Duplessis. I've got the fantastic Mr. Neill Friedman back with me for episode 2 in his deep dive series. So for those of you who haven't yet caught the previous episode, would highly encourage you to have a look at that. Neill walks us through some fascinating concepts from the different energy expenditure uses that your body has, from the life essential, sort of vital, non-negotiable, mandatory uses, heart beating, systems working, stuff like that, down into the more sort of still subconscious but a little bit more expendable, and then down into sort of the energy uses for physical activity and the stuff that you do purely voluntary. Really fascinating way to understand the breakdown of how your body uses energy, so I'd highly encourage you to have a look at that. And then we also went through the advantages of having process focused goals rather than outcome or reward focused goals, and why that's beneficial. So lots of great stuff in episode 1. We're here for episode 2. So Mr. Friedman, I wonder if you might give the audience a short synopsis of what you would like to discuss today, sir.
All right, so thanks, Ricky. Thanks for the introduction and the recap of last week. So our title for this week is How to Think Like a Scientist Without Being One.
Mm-hmm.
So really the focus of today is how to be a bit of a critical thinker, how to understand enough of the science to be able to try to work out what may or may not be relevant specifically to you, and kind of what the process for doing that is. And we're going to walk it through a process of seeing a headline on social media or the newspaper, and then how do you delve through that headline to then firstly see, is there science behind it? What is the science behind it? Is it supported by other science? And then we'll end up with kind of the critical bit is when you've been through that whole process, how do you then work out whether that's relevant to you as an individual, etc. So I guess the kind of important bit, or to highlight why I think this is important, because we're going to obviously in future episodes look more specifically at things like nutrition and energy expenditure, and our 3 basic rules for entry level getting yourself metabolically more healthy.
Yeah.
But the starting point is to be able to understand how to discern fact from fiction, for want of a better word. And the reason I think that everybody can identify a simple example is we're all told to follow the science. I think that was the big buzzword that came out of COVID, right? Follow the science. But how do you follow the science when the newspaper headline one day says scientists say 3 cups of coffee a day will make you live longer, and then the next day the same newspaper runs a story saying scientists say 1 cup of coffee a day will shorten your life? So what is it that scientists say? And how do we make sense out of that? So that's really, I think, the essence of what I'd like to do with people today, because unless you can think critically, follow the science doesn't make a whole lot of sense.
Yeah.
So I guess my starting sorry.
No, okay. There's a couple of things just before we move on. And I bring this up because I did my master's very late in life. I started it in my 30s. And I'll be honest, the first time I came across the term critical thinking, my gut instinct or gut feel of it was being critical of something and being like harsh on it, and sort of resisting it, or being how would you say, opposed to it.
Like a movie critic.
Yeah, pretty much. But that's obviously not what we mean. And I love the fact that you've used the term discern in your explanation of what you want to talk about, because that's really what we're talking about, isn't it? It's the ability to assess a body of information, whatever that information may be, and to discern what holds its weight, what doesn't hold its weight, because
this episode is brought to you by my work as a Zinzino independent partner. To find out more about Zinzino and their pioneering work in test-based personalized nutrition and how this can help you take the guesswork out of your personal health journey, please have a look at the episode description and complete the short survey linked therein. This episode is also brought to you by my new tech startup, Biosim Technologies. At Biosim Technologies, we are creating intelligent, technology-driven solutions for human metabolic health, empowering individuals to embrace a biology-first approach to their lifestyle, health, and wellness. To keep up to date with our progress at Biosim Technologies, please look at the episode description and join our mailing list, where you will receive periodic updates on the exciting things that we have underway.
Science, as I've come to understand in adulthood, is not black and white as you sort of are led to believe in school. It's a lot of grey, and it's a case of people taking the best information and the best data and the best resource available at a given point in time and making the argument that best fits the evidence. That changes, and depending on the sort of perspective you're coming at it from, the same data may infer different outcomes and so on and so forth. So it's really a case of being able to have a look at the argument put forward, have a look at the evidence that argument is based on, and deciding thereon what you think holds its water.
Yeah, so you lead me kind of into the sort of first question. I was actually going to pose a question, and that question is, what kind of person or what profession do you think is if they're doing their job properly, the least likely to follow the science? What type of individual in terms of what they do, if they're doing their job properly, will least likely blindly follow the science?
Well, it's hopefully a scientist, because you're supposed to
Absolutely.
be testing things and double checking and asking questions all the time.
So that's the whole point. So when people say just blindly follow the science, be aware that a good scientist, the exact thing they're going to do is not blindly follow the science, because the whole nature of science is inquiry, it's testing. It's why when papers get published, we go through a peer review process, and I'm going to talk more about that a little bit later and what that means. It gets a bit of a bad rep sometimes, but it's not a perfect system, but it's kind of the best we've got at the moment. And the whole reason that scientists put academic papers together, and in those papers, as you'll see as we go through in a bit, they are told part of the process is you need to publish your methods, because what has to happen is that other scientists should be able to replicate your methods and see if they get the same results.
100%.
And then compare the data. That's kind of the whole point. And even then, same methods in theory should produce the same results, but that doesn't necessarily mean the scientists will come to the same conclusions. And again, when we look to how we go through this process, it's something that people should be aware of, is that when scientists report their evidence, they report the results, and those should be hard, cold facts of what they saw. And then underneath that, they'll have a discussion section, and that's where they actually then use the body of literature that's out there, and they try to evaluate their results against that, and then they offer their interpretation of their results. But other scientists, coming from a different perspective, may interpret the exact same data differently.
Yeah.
How do they justify that? And can they justify it? And that's the scientific process. And the other thing that's really important, and I think you touched on it earlier, there's an expression that says that the nature of science is provisional. And what that basically means is that we only know what we know now, and that can change.
Yes.
So whereas political parties, and this is really topical for people who listen to this close to the current political discussion, because it was just yesterday, that in terms of our recording time, that the government did their big U-turn on their bill around payments, PRP payments,
Yeah, yeah.
etc. So scientists don't necessarily do a U-turn in terms of they just change their mind, but
Yes.
new data, new evidence must change and influence our thinking. Technology evolves at such a rapid rate that we can do things today in the lab that they couldn't do, not even 10 years ago, 20 years ago.
Yeah.
So that new technology may give us whole new perspectives that weren't there before. It doesn't mean that the previous people were necessarily wrong,
Yeah.
but their knowledge was delayed at the time. So we need to accept that the nature of all science, or the nature of all knowledge, is provisional. And what makes a scientist a good scientist is one who's prepared to change their life's thinking if
Yeah.
new
Yeah.
evidence emerges that simply makes them have to question it. So
100%.
yeah, so a scientist needs to question the science, and if scientists are questioning the science, then our viewers should also question the science. Don't take anything just at face value. So that's kind
Exactly.
of the starting point. So before we dive into the process, I don't know, Ricky, if you want to ask me anything or have any clarity on anything we've covered to that point.
No, I think you've unpacked that well. Both of us being South African, I think a sort of brilliant example of what you've just described would be Professor Tim Noakes, because you've got someone in the sort of sports science space who was incredibly prominent, world-renowned, a leader in his field, but pushed one model of sports nutrition. And then through his own experience and through emerging evidence later in his life, was then confronted with the fact that perhaps the model that he had been following was not the correct model, and had to wrestle that through, and had the integrity, because that's really what it comes down to, the integrity to admit that he was wrong before, and to correct his understanding and advocate for the better model of sports nutrition, which directly sort of conflicts what he had been putting out earlier in his life. And you used politicians as an example. I think many of us watch politicians flip-flop, and we sort of understandably get sick and tired of that going, look, just like pick a lane and stick to it. It just, but that they're just doing whatever they feel is popular at the time. They sort of flip-flop with what's going to be popular amongst the public, and it's a horrible way to conduct leading a nation, in my opinion, anyway. Whereas with science, I think it's the mark of integrity to watch a scientist evaluate emergent evidence, correct their own understanding, and then be willing to admit that they've been mistaken before or slightly incorrect before, and then go a different direction.
And saying all of that does not exclude the fact that you, like in every walk of life, you get dodgy scientists.
Mm-hmm.
You get scientists that fake their data. You get scientists that misinterpret their data. And we know more and more we have scientists who are influenced by whoever's funding them to support that organization, in which case there's a bias associated with that. So, I'm not saying all scientists are Puritans and that they're all giving the best evidence they can. They're human,
Exactly.
and like everybody else, there's good and bad, and a whole bunch of grey in between. So,
Yeah.
we do need to accept that, and that's why one of the things that I will show you now is how do we look when we look at a paper for we shouldn't base all our thinking on the work of one person or one group of people, and we'll look at that in a moment. So I think the starting point is to also then say, what is it that we see? What is it that the public sees that starts a process? And generally, it's a press release.
Mm-hmm.
And again, we need to understand the nature of press releases. So press releases, firstly, is the primary aim of a press release is to get printed somewhere, is to get published somewhere, right?
Yeah, it's to garner attention. Yeah.
Yeah, absolutely. So I'm a scientist. I do a bunch of experiments. I come up with some data. I send it through to the press office, the PR team at my university. Um, they read through this and go, "Oh, this is pretty boring." But then they see one line at the bottom and they go, "Oh, hang on, we can sell that. If we put that as the headline, then the press, the media will grab that." So suddenly you get a headline that's very attention grabbing and seems to make some sort of really big claim. And unless you go and dig deeper into that, it's quite difficult to know whether, um, you know, the press release might say one thing, but the scientists behind that might be thinking, that wasn't the point of my study, to be honest.
Yeah,
That wasn't, or that's a premature claim, or whatever it is. So what I'm going to do, Ricky, to get us going quickly, I'm going to share my screen.
Mhm.
And uh, share. And I'm going to open up this document over here. So I did a little bit of a trawl through social media earlier today, and on LinkedIn, I haven't put the person who posted. Somebody put an article around this headline over here. So this is a typical thing we'll see: inflammatory diet during pregnancy linked to child diabetes risk. Okay.
Okay. Yeah.
So that's quite a big claim, quite a big headline there. So the first thing I would say is when you see a headline that purports scientists say, studies say, evidence, whatever it is, the first thing you want to find when you read that article, that thing, is you want to see, is there a link to the source? Is there a
Yeah.
link to it? And sometimes that's a double link. Sometimes the headline will have a link to the press release, which will be the article in the Guardian or the Mail or whatever the newspaper is. Which will then have, as I say, the press release, and you then want to read through that press release to see, is there a link to the actual research? I would say that if you cannot find within the headline a link to an actual piece of research, what looks like a scientific paper, which has a format that we'll see in a moment, then you need to start questioning straight away what the validity of that statement is. If it's not supported by some form of evidence, question really hard and maybe
Yeah.
do some digging before you accept. So in the comments section of this particular post, the person who posted it put the link to the original study. So I clicked on that link and I have got it open. So that is the actual study that comes from that headline. So I'm going to say one thing, just looking at the title of that study, and I'll flick back to my open Word document.
Mhm.
Can you see a discrepancy up front, just in the title and the headline?
Yeah. Yeah. The headline on the LinkedIn article sort of overstates what the study was actually looking at and infers a conclusion that the study probably hasn't drawn just looking at the title of the study.
We'll dig into that, but there's something far more basic. It says here, inflammatory diet during pregnancy linked to child diabetes risk.
Mhm.
Can you see any
Okay.
statement there about whether that's type 1 or type 2? Is that type 1 or type 2 diabetes?
Yeah.
Yep. Whereas if you go to the study, it's specifically type 1 diabetes.
Yeah. So I guess for the audience, because not everyone might be okay with that, could you break down the difference between type 1 and type 2?
So type 2 diabetes is typically something we used to see more in older people, although the age that it's happening now is getting younger and younger and younger. And type 2 diabetes is very much associated with lifestyle. So we know that lack of physical activity, poor diet, overweight, obesity, etc., leads to type 2 diabetes.
Mhm.
Type 1 diabetes has always just been assumed to be something that you're born with. It's got nothing to do with lifestyle factor, although this headline now says maybe it has got something to do with lifestyle, but your mom's lifestyle, not the child's. So we've always said that. And the other fundamental difference, just to be a little bit technical on it, somebody who's got type 1 diabetes, their pancreas is not capable of producing
Yes.
insulin. All right. Whereas type 2 diabetes, normally you'll start off with a normal functioning pancreas, but your cells lose their ability to become sensitive to insulin. So your pancreas produces the insulin, puts it into your bloodstream, but your cells have little detectors, insulin detectors. And just to put that, just so I can try and explain that as simple as possible, for your cells to take glucose out of your blood and into the cell, a door has to open. I'm going to keep that. It's called a transporter, but it's very simple. Your cell has to open up a door that the glucose can pass through from the blood. Insulin is the key to that door. All right.
Yeah.
So you have an insulin receptor that picks up that there's insulin in the blood. And when it picks that up, it opens the door so that glucose can go into the cell. When you become insulin resistant, but basically somebody's put Prestic or putty or something into the keyhole. So the key is now circulating, but it's not going into the keyhole. So the door's not opening, which means that the glucose stays circulating in your blood. It doesn't go into the cells where it needs to be. All right.
Yeah.
That can develop through type 2 to get to a point where you've got so much circulating insulin that your pancreas then stops producing insulin in a similar way to type 1 diabetics. All right. But the process is different. With type 1s, your body just stops producing, or you're born not producing it, either way, stops producing insulin. And generally, you need to artificially add insulin to your system. So you need to inject yourself with insulin or have an insulin pump of some sort. All right.
Yeah.
So when most consumers, most of the people listening, see a headline about diabetes, the general assumption is it's around type 2 diabetes, because that's the one we most often associate with lifestyle. So they didn't mention type 1 in the headline grabbing article, but the study here is very specific to type 1 diabetes. So, and that's quite relevant, right? Because people always just think, oh, maybe it's just genetics that I've got type 1, or my child has type 1. And this study, and we'll look at whether it supports it, seems to infer that the mother's diet might actually influence whether a child is born with diabetes.
Yeah.
Next thing I want to just point out to people is just the naming protocol for most studies. And this isn't a 100% strict rule, but it's generally one that you can follow. And I'll tell you why it's important. So here you can see are all the authors that are involved in this study. And there's a whole bunch of them in this particular study. All right, so a study could have one author, it could have two authors, three, it could have as many authors as possible.
Yeah.
Generally, when you see a study, the first name, the first author, and often if you see a study, it says so and so and so and so et al., then the so and so and so and so before the et al. Is normally the name of the first author. This is generally the person who's done all the work. Okay, they will have been the person, if this is a lab experiment such as this one, they will have been the one that have done the majority of the work. Everybody, except for this last guy, normally there's some sort of boxing fight that takes place within the lab when they're ready to publish as to the naming order of the people that fit in the middle. All right. So depending on their role, depending on their input. But the other important one is the name that comes at the end. So the last name is normally the professor or the person behind the lab doing the work. Okay. It's normally his idea, and these are people that are working with him around something that he's looking to do. So in this particular case, I'm not even going to try and pronounce Mr. Olson's name, Sigurd, and I'm assuming it's a Mr., maybe it's a Mrs., I don't know, Sigurd Frodo Olson. But you can also see that he's also the corresponding author. So here's this person whose email address is on there. So this is his lab.
Okay. Yeah.
So effectively, you'll see with the ones and the twos, they're explained at the end where these people all work. But this Rohina will probably be a postdoc or a PhD student within Professor Olson's lab. And these could be other students or collaborators from different institutions who've all played a role.
Yes.
So here's the thing that's really important to look at that. Sometimes, and I'll talk about this after the study, you read a study and you'll want to say, well, is this supported by other research? Have other people come to the same conclusion and looked at the same thing? And so you'll maybe Google, I'll show you a little bit of a way of looking at doing that. And you'll see there's maybe 3 studies or 4 studies on the subject, and they've all got a different first author. So they all, if you just look at them randomly, it's, Norzia et al., and then it might be Kasperson et al. Does another one, and Sten et al. Does another one. All right, but the last author all the time is the same author. Then, though it's maybe 5 or 6 studies, what you then find is all those studies have come from the one lab.
Yeah, same lab, same sort of thought.
Yeah, and they've all got the same motivation for doing it. It's their subject, all right? It's what they do. So we, from the lab that I'm in, we take a bioenergetics approach to anything, and we're part of a lab called the Berg, which is the Bioenergetics Research Group. And my supervisor for my PhD and the person who runs our lab is Dr. Alexander Lehner. So any of the studies that we do, we have a study at the moment busy going through peer process. It'll have me as the first author, but it'll have Dr. Lehner as the last author. So if all the research that you see on our subject has all got Dr. Lehner's name at the end, then you know it's all just come from our lab. And then the question becomes, how come nobody else is publishing about this? How come nobody else is researching this? And that then becomes a red flag. All right. So when looking at a body of work, as I say, look to see who the last author is and try to make sure that it's coming from different labs. So that's my first bit of critical thinking to put through there. Next thing I want to quickly differentiate, now I don't want to go too deep into this, is all studies come in 2 formats: primary research and secondary research. And just to know what the difference is, primary research is where people have actually physically investigated something. They've done a randomized controlled trial, they've done the lab work, they've analyzed the data. Secondary research is where people have used other people's data to produce their own study. And there's nothing wrong with that. Often, though, it'll be like a review. So sometimes rather than you and I being the layperson, having to read 30 different scientific papers to get an idea, you can read a review paper which actually analyzes 30 different studies on that subject and then summarizes them and evaluates the data. And that can be very useful. But that's a secondary research because they didn't do the work. They're reviewing the work. You'll often see that couched as meta studies, meta-analysis. Meta-analysis is like a review analysis, but they actually crunch the numbers in a lot more depth. So there's a much more stringent protocol for doing meta-analyses. But again, it's still secondary data. So it's always quite important to look at. And then when people do reviews, when they publish those, they always have within their paper their exclusion criteria. So they'll say, this was the question we put into the search engine. 5,000 papers came back, but then we excluded 3,000 of those 5,000 papers for this reason, which left us with 2,000. And of that, we excluded these ones for that reason, whatever it is. And then it's quite important to see what those exclusion criteria are. Because if there's bias, very often that bias comes through in the exclusion criteria. So they end up selecting, the 5 studies that started off with 5,000, that kind of the way they filtered through it was always going to lend itself to one type of answer. So it's always important when you see those review studies to have a look at what the exclusion criteria were. All right. So the first thing you always want to have a look at within this is the abstract. So every paper that gets published has an abstract, and an abstract is just a summary of what's in the paper.
So it's like an executive.
You're not a scientist. So the first thing to always do is, even if you can't work through everything, always try and read the abstract. It's generally short and it gives you an idea, and it'll help you decide whether it's primary or secondary research. And generally, it'll also look at populations. And it's really, really important to actually, when you look at research, is who is the population and does it apply to you? All right. So just because a study was done in a mouse population, does that apply to humans? But then even in human studies, does that apply to you? It might be all in males and you're female, or vice versa. It might be that it was done in a certain age group. It might have done in trained populations. So they might have a study that says a ketogenic diet had these fantastic results for A, B, and C. But you look at the population and they go, well, all the people in that population had been ketogenically adapted and had been following a ketogenic diet for 5 years. If you haven't been following a ketogenic diet for 5 years and you're just thinking about taking one, the results of that study don't apply to you. Right? So let's have a look at this one over here. Let's have a look at what we see here. So here's the abstract. Starts off with a background. Sometimes that's just an introduction. So immune-mediated processes leading to childhood type 1 diabetes may begin in fetal life. All right.
Okay.
So quick summary of that. The causes that lead to children having type 1 diabetes may be something that happens to them when they're still a fetus in the womb.
Yes.
We hypothesized that a maternal inflammatory diet during pregnancy increases the offspring's risk of type 1 diabetes. So the hypothesis of this particular scientific lab was that they thought, or they wanted to look at whether the mother eating a inflammatory diet, and we need to know what they mean by inflammatory diet, and they will explain that, increases the chance of their child having type 1 diabetes. That's the background for what drove them to do their studies. Now, the methods are often, especially if they're lab-based stuff, really complicated. So you might not want to read it in the core of the data, but it's always important in the abstract just to try and get an understanding. Even if you don't understand word for word what it's talking about, try and get a feel for what they did. All right. So in this case, they looked at something called the Danish National Birth Cohort, which is called the DNBC. And this is a collection of data that was taken from parents or from pregnant women in Denmark between 1996 and 2002. So quite a date in there. In that data, they looked at them at maternal empirical diet inflammatory index score. So this diet had something called this EDII score, where they basically calculated whether the diet was high or low inflammatory based on a summary of 360 items. Okay. And here comes the part that maybe starts to become a little bit questioned. All right. So it was from a comprehensive 360 item self-administered food frequency questionnaire. All right. So basically, for 1 week, which happened to be the 25th or just before the 25th week of gestation, or while they were pregnant, 25th week of the pregnancy, they asked them, these moms to fill in a food questionnaire of what they ate in that week. All right. So this is a way a lot of diet studies are done, but of course it has room for a serious amount of error. All right.
Yeah.
Because people lie. And I don't mean that necessarily because they're evil. We lie to ourselves. All right. We fool ourselves, we miss things. And I always give a great example of myself when I was going through my weight loss process many years ago, and I was doing calorie counting. Science has moved on from there, but I was counting calories at the time. And I realized, because I'd been through the process before, that I was eating something that I wasn't accounting for. So I had, I'm trying to think what the common calorie tracking app is.
Like MyFitnessPal or
MyFitnessPal, that was the one, yep.
yeah.
And every time I ate, I climbed on my phone and I just put in the meal onto MyFitnessPal in order to calculate my calories. And it was very clear that I was eating more than I was counting. But I was missing it. So at one point, I just kind of asked my family, I just said to them, every time I eat something over this weekend, I'm going to reach for my phone and enter it in my phone. You tell me if you see me eating something and not reaching for my phone. Turns out that after the family had eaten, I'm sitting at the sink and I'm busy doing the dishes. Any food that was left over on the plate, I would just pop into my mouth to clear it off the plate before I washed the dish. Yeah, easily 150 to 200 calories per meal. All right. So I removed those from my diet, and my dog started putting on weight. But yeah, but if I'd done a food frequency questionnaire about what I'd eaten over that weekend, I wouldn't have added it, right?
No.
So we need to know whether something was done within the study to account for irregularity and what you do that, but also be aware that food frequency questionnaires, 24-hour diet recalls, all of these things are notoriously difficult to work with, to be polite about it.
Yeah.
But we also couldn't lock all these women for 1 week of their pregnancy into a metabolic chamber to make sure we could control everything they ate for that week, right? So this is kind of the best way of doing it. But again, when you see food frequency questionnaires or diet recalls or 24-hour recalls, be aware, or food diaries, be aware that there's always an inherent potential risk for that. And in any study you're reading, look at how the data was gathered and see whether you think, is there, in your logical mind, can you think where something may have gone wrong? And then when you look further down, did the people who ran the study account for that. So they asked them to fill out a food frequency questionnaire, which they had to complete around gestation week 25. The information on the covariates were derived from maternal interviews. So they asked a few questions when they interviewed these moms to be. Information on type 1 diabetes diagnosis in the offspring was obtained through registry linkage to the Danish Registry of Childhood and Adolescent Diabetes. So basically, they had access to the medical records, and the association between the EDI score during pregnancy and the child's subsequent type 1 diabetes risk was examined using Cox regression, which is a type of statistical analysis. Again, statistics and lies and all that. What's it? Lies, damn lies, and statistics. I'm not going to expect the audience we're aiming this podcast are to worry about statistical analysis, but that's what that is over there. All right. So basically, there's a very concrete quantitative part of this questionnaire in that they had the type 1 information that came out of people's medical records of the children, and then they linked that to this food frequency questionnaire from those same mothers, which is potentially where things may or may not have been 100% accurate. All right.
Yeah.
In terms of the results over here, again, this is a summary of the results, and often results, depending on the nature of the study, can be very confusing with things. So the idea is to just read it and try to get a flow. All right. So we included singleton live births and excluded confirmed maternal type 1 diabetes or type 2 diabetes prior to pregnancy. So effectively, in this case, if the mother had type 1 or type 2 diabetes before she became pregnant, the data was excluded because that's obviously could be something different. And they spoke about singleton births. In other words, they ignored twins or multiple births.
Yeah.
All right. And plausibility of higher low energy intake, which I don't know if they explain it here. I have looked further down the study already. So effectively, they wanted to see whether the self-reporting by the mothers was reasonably accurate. All right. And we'll skim down early and we'll look at how they did that just to give it an idea. But they wanted to make sure whether the likelihood of those 24-hour or those food frequency questionnaires was accurate.
Yeah, so they've taken sort of the middle of the bell curve. In other words,
well, basically what they did is they set a low and a high number, and they said anybody whose calorie intake for that week was per day was below a certain number, they would exclude on the presumption that was probably wrong. And anybody whose calorie intake was above their high number, which made it unreasonable, is probably wrong, which is probably quite a good way of doing things. But it also has the potential to leave out the most important information, right? Could it be that those few people who actually ate a really, really low diet, so they actually ate less than they ate less than the amount? Maybe they did some sort of intermittent fasting or something. I don't know.
Sure. Yeah.
Maybe that affected the outcome. And vice versa. Maybe those people who ate what was a stupidly high, maybe they really, really did eat that much and they were that high, and that could have had an effect on the outcome as well for their child. So by excluding those, they've tried to keep it within a realistic range, but potentially they could also accidentally exclude the most important data of all. So that's kind of one of the things that I would look at from a scientific perspective. But so it's something to consider. So they looked at 67,701 mothers. So it's quite a big study. Obviously, the bigger the sample population, the more likely it is to resemble general population. So that's a lot of people. And that's mother and child pairs eligible for analysis. 281 children were diagnosed with type 1 diabetes. So of these 67,000 mother-baby combinations, 281 of these children were later diagnosed as having type 1 diabetes. They then produced this EDI score. This is this inflammatory index score, where basically they said that a range was between -0.1 and -5.3 as being anti-inflammatory, and then to 4.1 being pro-inflammatory. It's quite complicated the way they've done this with standard deviations and things. And on the basis that we're trying to get the study to be legible to basic people, I'm going to just say, when you read this sort of thing, if you don't understand what they've done, that's fine. Just get the general analysis, right? Just get the general idea and try to take from it what you can. All right. So after adjustment for covariates, the incident rate of type 1 diabetes in offspring increased with an increased score by 16%. and that's with a 95% confidence interval. So I'm not going to worry about that. Per 1 unit increase in the EDI score. So effectively what their data said was that for every 1 unit that the mother's diet was more pro-inflammatory, there was a 16% greater chance of their child being diagnosed later with type 1 diabetes. So for
Do they mention
1%,
sorry, do they mention anywhere by what age the
I
child
haven't seen it here,
develops
but
type
remember,
1?
this is just the abstract, so we can have a click through. So here's the important part. Here's their conclusion. A maternal diet high in pro-inflammatory foods during pregnancy is associated with an increased risk of the child developing type 1 diabetes. All right?
Yeah.
That's their conclusion. And, if nothing else, you've kind of seen what they were looking to do, and they've actually concluded that their hypothesis is correct. And this is how they've done the study. Right. So that's the important part for someone to look at. You can then go through the rest of it. So basically, one of the good things that they've done with this study is they've given you a link to their data availability statement. Not all studies do that. Pharmaceutical studies, but definitely, or they try not to do that, although there's large amounts of pressure to try and force them to, but that's it compromises some of their intellectual property. But you know that a study is probably more likely to be genuine. Not genuine, it's the wrong word. But they've made their raw data available. So basically, they've said to the scientific community, this is what we did, and here's what our raw data was. You can try to reproduce our experiments and see if you get the same results. But more importantly, you can look at our data and see if you come to the same conclusion. So they're actually inviting.
Demonstrates a transparency that
elicits it's
trust.
Transparency. They're demonstrating a transparency. So they do that. So then they go through the study and they do a few things. I'm not going to go through all of this now, but what is already known on this topic. So they kind of list what was already known before they did their research, what they think the study adds to the research, and how they believe the study might affect research practice and policy going forward. And that's quite useful. You don't see that for many studies. That's quite a nice an idea. That abstract is taken from the bulk of the work. So this is now where I'm saying to the audience, in terms of understanding what you're looking at, how much of this you decide to read or don't decide to read is up to you. You may want to scan read it, just look for key things. Introduction normally sets the scene. So what is known in the literature, what's driving this research, why they decided to do it, what is the gap in the knowledge base that they're trying to answer. All right.
Yeah.
So I say I'm not going to go through all of this, but they kind of link through there. I just want to see to hear if they answer your question in this here, maybe in terms of I don't see them talking about at what age the type 1 diabetes looks at.
Because I mean, that seems to me at least like an important distinction, because at what point after birth does the infant's diet influence the onset of type 1 versus just the risk?
When does it become noticeable? When do the symptoms become noticeable? So they might turn around at this point when they took so they might turn around when they talk about the data that they collected. Maybe they answer that question because there'll be a date in the child's life that they would be collecting this data for. So let's see. All right. So now then they're showing their methods. And again, this is important. I said right at the beginning, what was the population that the study was done in? All right. Now, in this case, they're not very specific, but we can make a few minor inferrals, right? Because this was done in Denmark using Danish data. All right. It's probably fair to assume that the bulk of this population were white European. All right.
Yes.
Because they're Danish. All right. That's their thing. And they're and potentially we're also talking about in a cold climate. So when as an individual we're evaluating, so we're thinking about it, we need to think, will this apply to me? If I am of African descent and I've got a black skin and I'm living on the equator, will this data still apply to me? It might, but it might not. So this is just something that's why I say always kind of look at the population and ask yourself the question, does this apply to me? All right.
Yeah.
So here's how here's the nature of this questionnaire that was done over these years. and they go through all of that. I'm not going to go through it now. So what I do want to see is where if the interviews is how they collected this data. All women who answered the food frequency questionnaire were included in the study. It was 73,000 participants with missing linkage information were excluded. We'll look at it in the flow chart underneath. Mothers with multiple births, stillbirths, abortion, immigration, missing for unknown reasons confirmed type 1 diabetes or type 2 type 2. Yeah, those are the exclusion. All right, so this is just what's included them. So they've put a very nice flow chart here as to how they selected their data. So initially in this questionnaire cohort, there was 101,000 pregnant moms that took place. You can see that 28,000 of those were excluded due to a missing food frequency questionnaire. So they didn't complete we don't know what they ate in that week, so they had to be excluded. That left 73,000 people who completed that. Of those, 158 were excluded due to missing information. So they didn't fill in all the information properly, or there was something in the database that meant that their data wasn't complete. So they excluded them. So that left 72,852 parents. And then 5,151 of those were excluded either because they had multiple births, so they had twins or whatever it might be, or there were stillbirths, quite a high level of stillbirths there, or they didn't go to term, so abortions or something else happened, some sort of thing that excluded those 117. Mothers were confirmed as either having type 1 or type 2 prior to pregnancy. Those got excluded. And here's that dietary thing. So they've excluded people whose calorie intake was less than 2,500 or was greater than 25,000 calories per day. I would say if the calorie was 25,000 calories per day, it's probably fine to exclude that, because I'm not sure who's eating 25,000 calories a day.
But that's kilojoules, not calories.
Sorry, it's kilocalories. It's kilocalories. Again, you may want to look at the naming convention for that, because calories, sometimes people report it differently. What we call calories is actually kilocalories normally.
Yeah, there's a conversion for it. Give me a second and I'll pull it up. So kilojoules to calories is so 1 kilojoule is 0.239 calories. So 25,000 kilojoules is just under 6,000 calories a day, which is still a large amount of food.
Yeah, so I guess it's more. I guess it's plausible, but I can see why they've gone with that number. Although some people may well be eating, I don't know what 2,500. That's maybe less than 1,000 calories a day. So maybe it's
calories a day. So yeah.
Yeah, again, to be fair, they've probably got decent exclusion criteria in that respect. So that left them with 67,701 participants. So that's how they got from 101,000 down to 67,000. So that's quite a simple process to follow, and that's a reasonable thing to go through. They've got links to the figures. I'm not going to go through all of that. Okay. They've then got things like obviously the patients had to consent to taking part, and then this is where they got the outcome measures. So children were followed from the date of birth until type 1 diabetes was diagnosed, or the end of the follow-up, which was the 1st of June 2018. The date of type 1 diabetes diagnosis during childhood was obtained by linking the personal specific identification number. Again, I'm just trying to see if they got the data you were asking for. It seems like they've got it, but it's not published here.
Got it there.
All children today, which evaluated annually, covering all children aged 0 to 18. So they would have been diagnosed before their 18th birthday, but they don't say specifically at what point.
Yeah. So immediately there, like that throws big red flags to me, because how do you then differentiate? Let's take an adolescent at 17 years old, turning 18, who then develops type 1. At what point does their own lifestyle have influenced the potential onset of that? Like what in their environment, in their diet, so on
the
and so forth?
assumption that people often make, which is possibly incorrect, is that type 1 is not lifestyle based because it's not type 2. So therefore, this is either genetic or the mother's. That's what the kind of thing. But let's go through the paper because maybe they answer that question, right? It's a valid question. So let's just scan through as we go through and see that question's answer, right? So the mother's diet, so here they're talking about the empirical data. The mother's diet during pregnancy was assessed using these 360 food items from the questionnaire. It was validated against 7-day weighted food diaries and blood biomarkers. So they actually confirmed with some blood biomarkers. So that's interesting.
Nice.
It
Yeah.
didn't just take the food frequency. The detailed content of the food frequency questionnaire and data processing methodologies are outlined elsewhere. So they have got that in there. An inflammatory diet score for pregnancy diet was developed in the Norwegian mother, father, and child cohort study, and they've linked that in the references. So you can actually go and see exactly how that was created if you want to go that far. Which is similar but slightly younger cohorts to this one over here. So they're giving you some ideas of how this was done. The inflammatory diet score is based on methods previously described by, and there's the authors that did that, and that 9 says that's study number 9 in the references below. So if you want to see the previous one, you can go look for that if you want to. The EDI weights were derived in a subsample of 2,517 participants, that's the name of the study, with available biomarker measurements, who had a plasma concentration of C-reactive protein, or CRP, which is one of the standard ways in which inflammation is measured. Not the best, I might add. So often, if you're in the hospital and they'll check your CRP to see whether you've got inflammation, it's a very, very cheap and easy to conduct blood test, but it's not necessarily the most accurate. So the NHS uses it a lot because it's cheap. In brief, blood samples were collected from these mothers in mid-pregnancy, so between 18 and a half weeks, with 1.4 weeks either side of 18 and a half. The gestational week of blood sampling was not associated with the CRP value test. So basically, they're saying that these weren't done necessarily on the same day. So as I say, this is the kind of stuff you can go through depending on how much detail you want. The important part for the layperson is go through the abstract and go through some of this, especially if you have questions like the one Ricky's asked, and to scan through to see if you get an answer. So I just want to see if we get anything here as to the details for when they took that. No, it's all about the ERP. Here they talk about how they did the statistical analysis. I'm not even going to touch on this over here. If you're into maths and statistics, read it as much as you like. I will guarantee that 99% of the audience we're trying to appeal these podcasts to are not going to want to make head or tail of the stats. Most statisticians I know don't like to make head or tail of the stats. It's maths, really. So, but I suppose maybe just to give people a thing, what is the purpose of statistics? What is its purpose? The purpose of statistics is because obviously you want to know if the research you're doing applies to everybody in the world who falls into your population group, right? But you can't do a test for everybody in the world. So you do a test in a number, in this case, it's the 70-odd thousand people, and then you apply statistics to try and see how certain you think the numbers can be in scaling out to represent the whole population, the whole relevant population. So that's what
to help
statistics
understand the extrapolation.
Yeah, it's to extrapolate the data and say, if it happened to these people, will it happen to other people like them? That's kind of what you're trying to answer with stats. Here they then go through their results. And again, I'm not going to go through all this here, but they're looking at this either side of this EDI score, which is, say, you need to lead the previous study if you want to know exactly how that's calculated. Maternal pregnancy and offspring characteristics, and they explain it here, and they've got the tables and they've got the supplementary data. And again, we're trying to give people a basic idea of what we're doing here. So you don't need to go through all of that in detail. We won't go through all of that. But here's some stuff that might be interesting. Is you might want to open this table up somewhere, but how in this particular study, what do they diagnose as being inflammatory foods, right? So the kind of foods they asked about was red meats, dairy, low fat, pizza, margarine, potatoes, low energy drinks, French fries, etc. These were all things that they said would increase the EADI. So they've labeled all of these as being pro-inflammatory. All right. So I know Ricky's already got, if he had hair on the back of his neck, it would standing up because they've got red meats in there. So there's a potential red flag. By red meats, they maybe mean processed meats. I don't know. Yeah.
Maybe.
And then what do they talk about as being anti-inflammatory? Alliums, what is that? Tomatoes, whole grain. Again, I disagree with that one.
Anti-inflammatory.
Coffee, green leafy vegetables, fruit juice, dark meat. So a dark meat fish, sorry, tea and natural fruits. Fruits fell with these all fell within higher EDI scores. Okay. So that's all pro-inflammatory, I think, if I'm reading that correctly.
Put down as pro-inflammatory. That's
Yeah.
interesting.
Yeah, the risk of
I don't know that I agree with that, but that's probably.
Yeah, but again, you might want to look in the table where they actually go through all 360 foods and how they've grouped them, right?
Yeah.
So again, you can do that depending on how deep you want to go, but that is something that I would look at, right? So do I agree? Does the data agree with what they term as inflammatory foods and how they score it? So that's the data that they report on, and then they have their discussion. So as I always said, a discussion is their interpretation of the data. So this is where you can look at what their discussion is, and you can try to see whether you think they've interpreted their own data properly. And again, this is something where people just need to think and apply their own logic. They have very effectively. So within most good studies, they will actually show you what they believe are the limitations of their study. All right. So they've actually written this here. And again, from a time perspective, I'm not going to go through this all now, but they've produced what they think are the strengths and weaknesses of their own study. I mean, it's a bit like marking your own homework, but again, good scientists will be clear about this because they intend to do further research where they hope to pick up on some of the weaknesses of their study. Or they want to make sure that other people who follow up might be able to correct some of these things. All right.
Yeah.
So a good study will give you their own limitations. Then they've listed strengths and weaknesses in relation to other studies in the field. So they've compared theirs to others, which is good. And again, from a critical evaluation point of view, if you're not a scientist and you're just trying to make head or tail, the fact that they've just got those headings is a plus. All right. That means at least they're offering they are being critical of their own work.
Yeah.
Meaning of the study, possible explanation. And the word good scientists will always say possible, maybe, probably, rather than definitively, because it's all provisional knowledge. So possible explanation and implications for clinicians and policymakers. So this is them now taking their conclusions and saying, right, this is what we think clinicians and policymakers should take out of this. And I'm assuming that what they're going to be saying, I'm not going to read it now, but their advice will probably be, how do you get mothers, once they find out they're pregnant, to have a more anti-inflammatory rather than a pro-inflammatory diet, which I can't argue with, just as a basic rule of thumb. And they've got some conclusions. They've got their data availability. Again, just going through the end of the document, part of the thing that everybody should look at is, if they're working with people, or animals, is there ethical approval? All right. So have they been through some sort of an ethics board? That's quite important. And then look to see their acknowledgements. Some people will have their acknowledgements and their potential biases in terms of funding listed separately. Others will actually put who the funders of the study were inside their acknowledgements. In this case, I did have a scan through earlier. They're just grateful to all the people that helped them supply the data and etc. This doesn't talk about funding. They show that later, so we'll go through that. But it's always good to see who they acknowledge. Obviously, they'll just put through other people in their labs, but it might also be sometimes in the acknowledgements you might see a red flag. If somebody's showing that that lactose lactose intolerance doesn't exist, and I'm just making something up, and then they acknowledge help from the dairy board, that might be a red flag to consider. They then got their list of references. So you might, when you read something, and this is where I will give people if you have a very inquisitive mind like you and I do, this is where I'll give people a slight warning, is that sometimes you'll see something in the comment and they're referencing, oh, I want to read that. And then you quickly scroll onto the references and you click on that study and you go, oh, that's really interesting. And then inside that study, there's something else that you go, oh, that's really interesting. And they reference, and you then go into the references there. And next thing you know, you've been stuck in front of your laptop for 4 hours, and you're reading about, you're reading about why snakes migrate to the beach when you started reading about inflammatory markers, right? So you've just go down one interesting thing to another, and next thing you want to know why circus clowns scare people when you were originally looking at something about nutrition. Anyway, so so these are all that is you can get taken down all sorts of streams. So this is all their list of references. Here's their contributors, or all the people that have contributed to the study. So here becomes the one you want to look at. Who funded the study? Where did the money come from? All right. And they're always listed in terms of the most money, least. So the majority of this is the present study was funded by the European Foundation for the Study of Diabetes and the Lilly Program and the Juvenile Diabetes Research Foundation. You would then need to do your own homework if you wanted to see whether these people have an agenda or not. I don't know anything about these, so I'm not going to I can't do any of these. But there's the government, etc. Then there's the study here. The lead author affirms that the manuscript is an honest, accurate, and transparent account of the study. They've declared no competing interests. So by law, you should put their competing interests, but often it's buried in the funding rather than here, but they haven't declared. Provenance and peer review. So there was no provenance commissioned, but it was externally peer reviewed. So all the peer review process says is that when you publish a paper and it's going to get published in a journal or a respected journal, you submit the paper, an editor reads your paper and firstly sees whether they think it's, a lot of papers just get thrown out at the editor's phase. They read it and they go, there's not enough data here, the conclusions don't match the data, whatever it is. There's 1,000,001 reasons why the editor can throw something out. But if the editor says, okay, I'm interested in this, the editor will then send that paper out to a panel of peers. These are other scientists in the same or very closely related field. And the people who write the paper don't know who that's been sent to, and they don't know who it comes back from. So generally, you would want a minimum of 3 peer reviews to come back. And those peer reviewers, their job is to tear the paper apart and be critical of it. They may reject the paper offhand. They might say, we think this is rubbish, and say why. They might say this is fine, but it needs big revisions. This doesn't make sense. This needs to be changed. There's not enough information here. The data doesn't support the conclusions. They might give a number of reasons. It's then up to the original authors to then get all that feedback, and then they either make the changes that are recommended, or they make some of the changes recommended. But either way, they have to, when they resubmit the paper back, they need to answer every one of the reviewers' points, and they don't know who those reviewers are. So this process has the ability to be flawed because one of the reviewers may be one of your competitors. It could theoretically be somebody who's about to publish a similar paper and they want to make sure they publish before you. So they put a delay by holding your things up. There are quirks in the system, but overall, the peer review process is the best we have at the moment for making sure that data gets checked properly. All right. And all of that process has to be done before the paper then actually gets into the journal and gets published. So that's the peer review process that we go through. As I say, it's peer review can take a long time. I was looking at a paper. Actually, my supervisor were going through together the other day, where there's a paper. I think it's called a journal. Sorry, called eLife, and they're trying to overcome some of the potential hazards of peer review. So what they've decided to do is that they publish every single paper that gets sent to them, but then next to the paper, they publish the peer review. So even if the paper is wrong, they still publish it, but then they publish the peer reviews so that the readers can read the original paper and they can see what the peer reviewers came back with. And you can see some things. And so that's a different way of doing things. It's a bit experimental. It's a bit experimental, but one of the papers that we were looking at, we saw the original paper. We then saw the peer review, which was hugely critical of the actual science that was done in the lab. And then we saw the final paper that ended up getting published. And the interesting part of that is the dates between the original submission and the final submission was 2 years. The lab spent 2 years correcting all the peer review feedback that they got. They went back into the lab and they took all the and they redid the work. So that is exceptional. 2 years between first submission and final submission to get the So that's not typical, but it could
No.
be anything from a couple of weeks to up to 2 years, but normally a couple of months is the process of going through that. All right. And then they've got their links to their supplementary material, etc. So that's the first thing. So now we have a study, we've reviewed it, we've looked at the different details, and we think, you know what? This kind of seems to be making sense, right? This I'm kind of agreeing with this. The question becomes, this is one paper. So as we said earlier, how do we know this that have other people done this? Do other people agree with the same thing? So what we need to look at for critical evaluation is trying to look at, are the other papers to support this? Is anybody else looking at something similar to this? So I've basically just taken that and I've defined it into that initial document that I had just to save a bit of time. Is I thought we're going to sum that up into this question over here. Is we want to see other papers that say copy other papers that look at type 2 diabetes. Oh, I said this is type 1. So are there papers that look at type 2 diabetes as a result of maternal diet? We've already said this headline doesn't say type 1 or type 2, but we've now reviewed the paper and we've seen this is referring to type 1. So what's the body of literature saying about type 2? So here comes the bit that I remember. I've become a bit blasé about this now because I've done it so many times. But I remember the first time I ever heard of, I went through this process, and that was the fact that most of your listeners might not know there's a whole other Google out there, right?
Yeah. Yes.
There's a whole other Google out there. And and it's not the Google that you will generally look at, but if you're looking to see if there's a body of work, there's something called Google Scholar. Now, I always remember before I've been to university, whatever, when I was first studying nutrition, I remember I had a question about sports nutrition, something that I now think of as being pretty basic. I can't remember what the question was, but I managed to get myself onto the ISSN, which is the International Sports Science Network, the International Society of Sports Nutrition. I got onto their closed group on Facebook, where all these PhDs and doctors and postdocs in sports nutrition sit and question. And I posted in there very naively my very simple, not very sciencey question. And I got some very arrogant responses, which maybe is not the science looking in its putting on its best show. But I remember someone saying, just check this on Google Scholar. And I went, what the hell is Google Scholar? Never heard of that. So there's my Google page. If you go into your search bar and you literally type in Google Scholar,
There we go.
there it comes up. I'm going to go to the first one, Google Scholar. So that's what Google gives you. And you can then click on Google Scholar. And now you've got a different Google, right? Now you've got Google Scholar. So Google Scholar is an entire Google search engine just devoted not to science, but to academia. All right.
Yes.
So
Academic
it doesn't
articles,
necessarily be science. It could be all sorts of non-sciencey things, but it's academia. It's where academics post their, it gathers all this research. All right. And of course, it looks very, very different to the headlines and the stuff you'll see in Google Scholar. So if we now go into this Google Scholar search bar, and if I paste in what I put in earlier and say search. So here we go. Here we've got a whole bunch of studies that actually kind of look at this question. So they contain the terms type 2 diabetes as a result of maternal diet. So here's one saying maternal high fiber diet protects offspring against type 2 diabetes. These are the names of these studies: maternal diet and gestational diabetes, mellitus development. And this is quite a popular subject, by the way. But you can see that there's, pages and pages of study. In fact, you can see there's more than 10 pages of studies here. Okay. And as you can see from the change of color, I clicked on one of them earlier. I clicked on this impact of maternal diet during pregnancy and breastfeeding on infant metabolic programming, because that just kind of interested me within this. So again, from a very basic point of view, if you put in your question relating to the study you've looked at and you get loads of answers, you now start to get an idea that actually there's quite a few people researching this. And now you can maybe just click on one or two of these that seems to ask the same question and just quickly read the conclusions in the abstract and see whether they confirm or deny the first paper that you read. Right?
Yeah.
You may find within some of those that you'll find a review. And that's great because then you can see that the reviews actually assessed 10 papers or 20 papers and 30 papers and come up with those. So click on that one so you can see the study was the impact of maternal diet during pregnancy and breastfeeding on infant metabolic programming, a prospective randomized control study. You can see the authors again here. So you can see there's an and here. So this is a lab run by two people. So these two over here will be their lab. This will be the first author that did all the work, and this will be someone else that's contributed to that, as we discussed earlier.
Yes.
You can download the PDF if you want to. But here again, you can see what were their objectives, what was their subject methods, what were their results, and again, you can get an idea what was their conclusion. So modification of maternal diet during pregnancy and breastfeeding may benefit infant metabolic health. High split pro-insulin reflects adverse metabolic status in infancy, which can be improved by early dietary counseling. So counseling the mother in this case. All right.
Yeah.
I'm not going to go through, we've been through the process of doing that.
Yeah.
So you can do that. One thing you can do with Google Scholar, and this is quite an interesting little thing. So if I just go to the top of the page here, with Google Scholar, you can, if you've got an interest area that you're really interested in, you can create alerts. All right.
Okay.
So I don't want to create that. What I want to do is I want to go to my profile. Sorry. And I want to go to my alerts. There we go. So you can see that I've created for myself alerts that I've set up to send me every 24 hours. And these are the subjects that I want alerts on. So this is now related to my research. And you can just add a new alert and you can say you want all the results or just some of the results. So I get, and again, I just put it into the printout that I had earlier. I get every day in my inbox. I took a snapshot of this earlier. That's just a snapshot from within my inbox. You can see these are all from Google Alerts on each of those alert subjects. And if I then click on those, I get to a page of all the studies published. I get these every 24 hours. All the studies published in the last 24 hours on my subject area.
Okay.
So if you're interested in something specific, so if this particular paper, for example, so if you're thinking of having a baby and you want to know how your maternal diet may affect the outcome of the health of your child, you can set up a few of those questions in Google Alerts, and then you don't have to. Then every single day on whatever those subjects are, you can set it up for 24 hours or weekly. So up to you how often you want to get these alerts, and you will then be able to get those, and you can do the evaluation. You can see the work. So that's just really a very basic process of then confirming whether there are other studies that back up the headline. So remember where we started with all of this. Our starting point with all of this was that scrolling through social media, we saw that attention grabbing headline.
Yeah.
Right. So I think everything we've done.
I think just being a bit of a devil's advocate here, what you're highlighting is that to be someone who thinks critically is not a quick and easy process, and it shouldn't be, because if you're going to be evaluating stuff in detail and trying to make your mind up on a topic, you need to be willing and able to put the time in to read and understand. And so the immediate problem with that is you can't care about everything. Like people just don't have that kind of time. So people need to be a bit selective in. You're not going to go and read in. Maybe you are. I'm not going to go and read in full detail every single study associated to every topic that I come across that I may agree or disagree with. But what I am going to do is, if I come across something that really challenges my thinking, I'm going to at least look at the abstract and the results and see whether they match up with the headline. And if I'm finding something a little bit funky there, or there's something I want to know more about, I'm then going to look further into the study as you've just walked us through, and then to other supporting studies, so on and so forth. So for topics that really matter to me, I'll use a personal example. My son has autism, and so I spend a lot of time trying to understand the emergent literature around lifestyle factors and how to improve the outcomes of children with ASD. But I'll be very clear, there's no cure for ASD. There's no magic sort of button to push to switch it off. But there are things that you can do as far as lifestyle factors are concerned to help the kid develop as best they can and to be the best version of themselves going forward. Likewise, in the absence of certain interventions, you stagnate or stump the potential development of that child, and it ends up with them not advancing as they should. So it's a bit of a two-edged sword. There's things you can do to help them. There's things that if you don't do it, you're doing harm to them. And that's a tough one to wrestle with because it's a very difficult path to navigate. But so I will spend the time looking at stuff like that in depth and in detail.
It's very important. Absolutely.
Yeah, but for a topic that isn't that personal to me, I'm not going to invest that kind of time. I may look at a headline and go, that doesn't seem right. Let's have a look at the studies involved. Does the abstract fit what the headline says? Yes or no? And does the results match up accordingly? Yes or no? And then make my mind up sort of quick and easy like that.
So you can take what we've been through today into as much or as little as you want. You may decide, you being the listener may decide that actually you're going to just take step one of all of that. You're going to look at the headline and say, in the headline, do they link to an actual scientific study? If not, I'm going to maybe not take it too seriously. Yeah. If it does, I'm going to consider it without even doing all the rest of the stuff that we've done. The fact that there is a study behind it, that might be good enough for you. All right.
Fair enough.
It's how deep you want to go. How important is the subject to you? But the more important the subject is, probably the deeper you should go before you just believe. All right.
Yeah.
And even then, after all of that, in fact, no, pause a second. I'm going to come back to that. We've all seen the statement. I just want to give a few watchwords that come up. Causation, correlation doesn't equal causation. All right. So we know that a lot, but also correlation and causation doesn't necessarily preclude each other. Sometimes the only option we have is to look at correlation, right?
Yeah.
Because we don't have an ability to look for causation. Sometimes the perfect scientific model doesn't exist, all right? I'll give you a great example, climate science, all right? I'm not climbing on board or against climate science right now, but climate science has to work on modeling, all right? You cannot do a random controlled trial on the effects of our impact on global warming, because to do that, we would need a control planet Earth. Right?
Yeah,
we would need to have a completely separate universe with a different planet Earth in it, and then do all the stuff that we're doing to our one here and not do it to the other one and compare the differences. And then we can say we've got a control study where we've compared our intervention with a control. So all we can do with climate science is model and use the data and evidence that scientists can do to try to prove or disprove a point. All right. So that's not a great way of doing things, but there is no alternative with climate science. There is no second planet Earth as a control. So sometimes correlation studies are the best we can do. And I'll give you sort of an example when I'm going to answer two questions around our space at the same time. So there's a lot of debate about using BMI as a marker for obesity or fat in terms of doing studies, right? So we've got this general statement that BMI below 18 is underweight, between 18 and 25 is healthy, between 25 and 30 is overweight, and 35 plus is obese. Those are the rules, and I will specify that those rules only apply to a white European population. We know that metabolic health disadvantages, or not disadvantage, the wrong word. The illnesses that we relate to somebody having a BMI between 25 and 30 in a white population, in an Asian population, are actually between 22 and 25. So your BMI, what is deemed a healthy BMI for your average white male, is not necessarily a healthy BMI for a Asian female to take those. So be aware that BMI studies also have cultural differences. But people will often say BMI is a awful measure because it doesn't take into account muscle mass. All right. So I may have a BMI over 30, but that could be because I'm an Olympic bodybuilder. Right. I'm not.
Yeah.
Yeah. In which case
Well,
I might have like
my BMI is 33.5.
Yeah, but your
But
body fat percentage is below 20,
so
right?
according to that, I'm grossly obese. Oh, a
Yeah.
lot, but yeah.
So when you're looking at individual stuff, BMI is not a great story. However, when you're trying to infer population-based statistics,
Mm,
the vast majority of the population who have a BMI over 30 have so because they are obese, not because they're bodybuilders.
yes.
All right. So when you look at big population studies, the errors involved in BMI get smaller and smaller and smaller. So the more people in the study, the smaller the percentage of the error is. So if somebody's saying we have a cohort like our other one where we have 75,000 participants, and we deemed everybody to have a BMI over 30 to be obese, the chances are that 95%, I shouldn't give numbers because I'm making them up, they're not statistically accurate, but the chances are that the vast majority of those people with that BMI are in fact obese. All right. So BMI, so correlation studies that work with BMI with big cohorts, because you can't do a control study with 5 million people, right?
Yeah.
But you can say that of a population in the UK of whatever million here, 5 million the NHS is showing has got a BMI of above 30. And of that, and that relates to an equal percentage of people dying before they're 70. I'm just making stuff up now, but you get the point?
Yeah. Yeah.
So you could say, well, correlation doesn't equal causation because that correlation is talking about BMI and they could all be bodybuilders. Well, 5 million people,
Yeah, they're not all bodybuilders.
maybe 500,000 of them, or maybe even 100,000 of them are bodybuilders, right? The rest are in fact obese. So in that case, in that kind of study, the potential is that correlation might be causation, or it might be reflective of causation, not being the actual causation. So don't always be in such a hurry to dismiss those because correlation, but likewise saying that, in counties where the county council accidentally hangs the British flag upside down, also sees the highest number of people dying from diabetes. So therefore, hanging the flag upside down causes diabetes. Clearly, in that case, correlation does not equal causation. So you've got to apply some logic. And then I think the last thing that I wanted, yeah. And then I think the last thing that I want to touch on is that after that whole process, let's say you found something, you're interested in your metabolic health, you've seen a headline, you've gone through this whole process that we've been through, you've been through it all, and you've come to your conclusion that actually it looks like that study is correct. That headline is potentially correct. It all makes sense. Then you've got one last question you need to answer. Does it still apply to me?
Yeah.
All right. Because within every study, you have outliers. You have people that conform to the data, but you generally have people that are above the data or below the data. And for all you know, you may be an outlier. All right.
Yes.
So after all of this and after all the scientific evidence and everything that you've done, you need to try it, see if it works for you. And if it doesn't, that doesn't mean there's something wrong with you. It doesn't mean you're a genetic misfit. It doesn't mean the science was wrong. It might just be that you just are an outlier to that study. Or it might be that your lifestyle just doesn't allow you to do that. Go back to the goal setting we spoke about in the last episode about making sure that you match your goals to what is reasonable within your lifestyle. All right. So it might be that, people who, I don't know, go for a 10-mile swim at exactly 3 o'clock in the morning every morning, lose weight. If you work night shifts, that's not going to work for you because you're working at 3. So I'm trying to be extreme, yeah. But the idea is really once you've been through all the evidence and you've done all the science, do what they call an N=1 study. Try it on yourself. And if it
Yes.
works for you,
Self
brilliant.
experimentation is a must at the end of the day.
Yeah. And just be reasonable, like, and just be within that. And that is becoming, that's, I think what we're trying to say here is that's empowering people to experiment on themselves.
Yeah.
Right.
Okay. So if I was trying to summarize the key points here, I would summarize them as: be wary of just believing headlines at face value. Double check, is the headline and or the article in the media, whichever form of media it is that you've had that headline grab your attention, is it linked to a supporting study? If it is, great. Does the supporting studies title, abstract, and results align well with what the headline says? And then, depending on your level of interest, you can go further down into who the authors are, the methodologies used, are there other studies that support this? But then at the bottom of everything is, does this apply to me? How do I find out? Well, I've got to give it a try if it's something that needs to be tried.
Yep. I think that sums it up really nicely. So yeah, just be in your own words, be a little bit of a scientist. Be critical. Don't just accept.
Yeah.
And don't let conflicting things put you off. Try to dig into why there's conflicting stuff, and sometimes there's really good explanations. It might be that cup of coffee analogy that we spoke about, that when you dig into it, the 3 cups of coffee a day is really, really good for you if you happen to be a white female aged between 21 and 24. And the 1 cup of coffee a day might shorten your life happens to be if you are a Asian male aged 90.
Yeah.
So that it could be that simple. It could be more complicated, but that might be why they got these conflicting headlines. So look at that. So I think that's kind of, I don't want to get too much into today. Probably worth speaking that next episode 3 in this series, we're just calling Nutrition 101, and we are going to really take a shallow dive rather than a deep dive. A shallow dive into nutrition. No, we're going to look at the 3. We're going to look at nutrition, and we're going to hopefully give people 3 nutritional interventions that they may choose one of for themselves. So I think if we go back to episode 1, we said we're going to create a 3x3 matrix. So the 3 down, if you like, is the 3 things that you can do, or the 3 aspects that you should look at to improve your metabolic health, those being nutrition, physical activity, recovery. And then we said within each of those 3, we're going to create 3 basic rules. And the idea is that we want you, the listener, to be able to choose one from each. So 1 nutrition intervention, 1 physical activity intervention, 1 recovery intervention. Apply those that fit to you. And we think that by doing that, you'll get the most bang for your buck in terms of starting your road towards improving metabolic health if you don't know where to start. So Nutrition 101,
Looking
episode
forward to that. Well, Neill, thank you very much. That's been a brilliant one. And I'm sure I think out of all of them, this is the one that's going to give people the most sort of cognitive dissonance, because there is a lot of effort involved in critical thinking. It's not something that's easy. It's not spontaneous, and about that being able to spontaneously sort of evaluate things, that comes from hours and hours and hours of spending time in the literature and building an understanding of the body of literature. And there's no substitute for that. You have to get into it if it's a topic that interests you.
And don't be scared to Google words. So you're reading a study and you see words like mitigate or mediate, or sometimes, unfortunately, one of the things that scientists do like to do is they can have a simple word or a very complicated word to say the same thing, and they default to the complicated word, or they start producing word salad where they start really using the most highbrow English they possibly can to explain something that's basically quite simple. It's very, very annoying. But don't be scared if you're reading something and you go, this seems to mediate that. And you go, well, what do they mean by mediate? Highlight the word mediate, drop it into your normal Google and hit the meaning bit and just see what they mean.
Yeah. Good stuff. Well, thank you for your time, sir. Looking forward to the next one.
Brilliant.
Thanks, everyone.
Cheers, everybody.
Ladies and gentlemen, thank you very much for watching the episode. I hope that you found the conversation meaningful and informative, and I hope that it has empowered you with some tools and insights that you can take to tweak and improve your own lifestyle approach in pursuit of optimal metabolic health outcomes. If you've enjoyed the episode, and if you're enjoying the podcast, I'd like you to do me the kindness of please subscribing to the channel, giving it a like, maybe even giving it a share. Help to raise awareness and get the podcast in front of as many viewers as possible, because it is my passion to try and help as many people as possible to understand more of the nuance around metabolic health and how to tweak their lifestyle in pursuit of optimal outcomes. Also, if you have any constructive feedback, things that you think I could improve on, any critiques, any criticisms, please do feed them back. I give you my solemn word that I will take them seriously, and I will, to the best of my ability, work to improve and to give you a more refined and more targeted product as a result of your feedback. So I will take it seriously, and I'll do what I can to improve the show. But again, thank you very much for watching. Keep thriving.